Hi friends, in this video we are going to discuss about the concept of resistance calculations. So in any circuit, if there is a presence of combination of resistances means multiple resistors are present in any circuit, then to find the total equivalent resistance for that particular circuit, so we need to follow the two different types of connections. Okay, so the question is to get the equivalent resistance in any circuit. So we are going to calculate the equivalent resistance based on the basic two different types of connections. So basically we have two different types of connections are there. One is series connection, the second one is parallel connection. Okay, so here first thing is series connection. So series connection means how the two resistances are connected. Okay, just see here we have one circuit that is R1 and R2. R1 and R2, if these two are connected directly like this, then this type of connection we are calling as series connection. Okay, so just see here, for example, R1 having two terminals, one is left side, another one is right side, and here R2 consisting of two terminals, one is left and one is right side. So just see the connection between the R1 and R2. The left side terminal of R1 is connected to the right side terminal of R2 directly like this. So this type of connection we are calling as series connection. Okay, so the question is, just see the question here, calculate equivalent resistance if R1 and R2 are connected in series. Okay, now the value of R1 is equal to 20 ohms, R2 is equal to 80 ohms. Now whenever two resistors are connected in series, then to find equivalent resistance we can directly add the two different values of resistances. Okay, just see here. So R1, R2 both are connected in series, then R equivalent is equal to R1 plus R2. Okay, just see here. So this one. So R equivalent is equal to R1 plus R2. So here R1 is 20 plus R2 is 80. So by adding these two, we are getting 100 ohms. It means that whenever the two resistors are connected in series, then to calculate equivalent resistance, we can directly add the values of resistances. Okay, for example, we have another question here. Just see here, calculate equivalent resistance for the following figure. Okay, the question is what, calculate equivalent resistance for the following figure. Now just see here, this one is a given figure or given circuit. Now how many resistances are there here? R1, R2, R3, R4, and here all these four resistors are connected in series. It means what? So between R1 and R2 we have one common point, and between R2 R3 we have one common point, and between R3 and R4 we have common point. With the help of these we can add all these resistances like this, then this type of connection we are calling as series connection. Now our target is to calculate the equivalent resistance for this particular given figure. Okay, now we know that whenever resistances connected in series, to calculate equivalent resistance we can directly add all the values of resistances. So that is the reason why, just see here, R equivalent is equal to R1 plus R2 plus R3 plus R4. Now by substituting the values of resistances in this, so R1 value is 1, R2 is 2, R3 is 3 and R4 is 4. So by adding all these values we are getting R equivalent is equal to 10 ohms. Okay, so this type of connections we are calling as series connection. Okay, I think you are clear. Now Coming to the second type of connection, okay, that is parallel connection. Okay, now see here, R1 R2 both are connected in parallel. Okay, it means that we can directly say that the right terminal of R1 is directly connected to the right terminal of R2, and here left terminal of R1 is connected to left terminal of R2. Okay, this is the actual connection or actual procedure to connect resistors in parallel. Now see here, so R1 R2 are connected parallel like this. Now the question is, find the equivalent resistance for this particular circuit. Okay, now the most important point is, whenever two resistors are connected in parallel, to calculate equivalent resistance we need to consider the reciprocal of resistance. Okay, just remember, in series connection we are directly adding all the values of resistances, but in case of parallel circuit or parallel connection, we are considering the reciprocal of each element. It means that addition of reciprocal of each element gives the equivalent resistance of any parallel combination. Okay, so that is the reason why here just see 1 by R equivalent is equal to 1 by R1 plus 1 by R2. It means just see here, reciprocal of R equivalent is equal to reciprocal of R1 plus reciprocal of R2. So that we are calling as, whenever we are getting or we need to get the equivalent resistance for parallel combination, we need to consider the reciprocal of equivalent resistance and reciprocal of individual resistances. Okay, the addition of reciprocals of individual resistors gives the value of equivalent resistance. Okay, so that's, so 1 by R1, sorry, 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Just see here, simplifying here, take LCM, you will get R1 into R2, and by simplifying you will get R2 plus R1. So here 1 by R equivalent is equal to R2 plus R1 divided by R1 into R2. So 1 by R equivalent is equal to R2 plus R1 divided by R1 into R2. But we required what actually? We required R equivalent. So that we need to take the reciprocal of that expression. So it will gives, so R equivalent is equal to R1 into R2 divided by R1 plus R2. Okay. So like this we can get the equivalent resistance for parallel combination of resistances. Okay. Now see the simple problem here. Calculate equivalent resistance for following figure. Okay. Now see here, R1 R2 both are connected in parallel. Okay, both are connected in parallel like this. Now we need to find the equivalent resistance for this particular given figure. So here 1 by R equivalent is equal to 1 by R1 plus 1 by R2. 1 by R equivalent is equal to 1 divided by the value of R1 is 1 plus 1 by the value of R2 is 2. Just by substituting these two values here, so you will get the value of R equivalent. By simplifying, you will get the value of R equivalent is equal to 2 divided by 3 ohms. Okay. So this is about the series and parallel connection of resistances. Okay. For example, we have another problem, and in that problem, for example, 10 resistors are connected in parallel. Okay, 10 resistors are connected in parallel. Then our target is to find equivalent resistance for that particular parallel combination of 10 resistors. Then how to find the parallel, how to find the R equivalent or equivalent resistance for the parallel combination of 10 resistors? Simply by considering what? 1 divided by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus up to 10th resistors. By simplifying that, you will get the value of R equivalent. Okay. So this is the procedure we need to follow whenever we are going for the calculation of equivalent resistance when the resistors are connected in series and also in parallel. Okay. Thank you so much for watching, and please do subscribe my channel for more updates. Thank you.